Hello guys, and welcome back to a new video. Today's video is on something called partial fractions integration. Partial fraction integration is basically finding partial fractions of something as to make it easier to integrate. So our first equation today is the integral of 1 over x squared plus 4x plus 3 dx. So the way we're going to do this is we're actually going to find a quadratic equation for x squared plus 4x plus 3. So what is multiplied to 3 but adds to 4? In this case, it's going to be 1 and 3, both positive. So now we know how we can make our quadratic equation. It's like this. There we go. Okay, so now we can use partial fraction integration to work this out. Okay, so to do this, we are going to split it into two different equations. So this is going to be equal to the integral of a over x plus 1 dx plus the integral of b over x plus 3 dx. So this is going to be what we are going to work with. Okay, so you might be wondering, how do we know what a and b is equal to though? Well, we're going to do something special to get it. Okay, so for now, we'll just get rid of the integrals and the dx's. So we get this equation. 1 over x plus 1, x plus 3 is equal to a over x plus 1 plus b over x plus 3. Great. So now we've made it more simple. And we're going to actually find a and b through this by multiplying this whole thing here by this. X plus 1, x plus 3. So let's write that in. Okay, sorry, that looks really bad. So this is going to make it so that it is equal to 1 is equal to a multiplied, alright, by x plus 3. X plus 3. Okay? This is because the x plus 1 cancels out the denominator, so it is being multiplied by x plus 3. And b, you can probably see, is going to be multiplied by x plus 1. This is because the x plus 3 will cancel out the denominator, so we're left with x plus 1 multiplied by b. So now we can go ahead and set x values so as to find our values for a and b. Okay, let's do this. Okay, first let's set x equal to -3 as to cancel out this 3 here. The reason we're doing this is so that this here becomes 0, and a multiplied by 0 is 0. Okay, so that is going to leave us with a b value. So let's go ahead and work this out. Okay, x is equal to -3 for this part. Okay, so that means that 1 is equal to a to the -3 plus 3 plus b, sorry, that is a horrible b, plus b, oh dear gosh, plus b. Okay, well, I think that's as good as we're going to get it. To the -3 plus 1. Alright? So that means that 1 is equal to b times by -2. Okay, so that means that 1 is equal to -2b. Okay, so you can go to your calculators now and calculate what 1 divided by -2 is. Or if you want to do it in your head, that's fine. So this is going to be -0.5. So that means that -0.5 is equal to b. Okay, now we want to find a. Okay, so 1, right, is equal to a times by x plus 3 oh dear gosh, plus b times by x minus plus 1. Great. So now we are going to have to find a. The way we're going to do this actually is by setting x equal to -1, as to cancel out the 1 in b times by x plus 1. So we get b to the 0, which is 0. Okay, so set x equal to -1, and this means that 1 is equal to a to the -1 plus 3. Plus b to the -1 plus 1. Sorry about the really bad writing today. My pen is refusing to cooperate. Anyway, so that means that 1 is equal to 2a. Okay? So if you divide 1 by 2, because obviously 2a divided by 2 is a, so 1 divided by 2. So 1 divided by 2 is 0.5. So that means that 0.5 is equal to a. So let's write this down while we solve our partial equation. A is equal to, and b is equal to. So a is equal to 0.5, positive 0.5, whereas b is equal to -0.5. Great, so now let's plug them into the equation. The integral of 0.5 over x plus 1. Just let me quickly check. Yep. integral of a over x plus 1 plus integral of negative 0.5 over x plus 3. Okay, so now we can actually move the negative from the negative 0.5 to the front of the integral. So this is equal to the integral 0.5 over x plus 1 dx minus the integral of 0.5 over x plus 3 dx. Great. Now we can integrate. Okay, to integrate these two things, we need to know this. The integral of 1 over x is equal to the natural log of the absolute value of x. Whereas the integral of, let's say, 4 over 7x plus 3 is going to be equal to the natural log of 7x plus 3 all multiplied by 4. Okay? So we're going to do the same thing here with this. My pen is so unresponsive. Okay, so the way we're going to do this is, I'm gonna just rewrite it quickly so I remember the values. Great. So the way we're going to do this is by taking the natural logs. Okay, so this is going to be equal to the natural log of the absolute value of x plus 1, because you can't have negative values inside a logarithm, times by 1 over 2, or 0.5 in this case. So this is going to be subtracted by 1 over 2, as is a 0.5, natural log of the absolute value of x plus 3, and then all plus c. So that is our first equation for partial fractions integration. And our next equation is going to be integral of x over x minus 1 x plus 2 squared. Okay, so that is going to be our second partial fraction integration problem. Okay, so the way we do this is we turn it into partial fractions again. So this is actually going to look like the integral of x over we can actually go straight to the partial integration. So the way we do this is the integral of a over x minus 1 plus b, integral b over x plus 2 plus the integral of c over, and then it's going to be x plus 2 squared, right? X plus 2 squared. So the way we have it is we have both the fraction, we have both the value inside and we have the value as a whole. Okay? So we are going to go and look for the A, B, and C values now. Okay. So that means x over x minus 1 times by x plus 2 squared is going to equal a over x minus 1 plus b over x minus plus 2 plus c over x plus 2 squared. Now here we're actually going to multiply by this thing here, this denominator, this whole expression, x minus 1 x plus 2 squared. Now this is going to become x is equal to a times by x plus 2 squared, okay, plus b multiplied, watch this, x minus 1 x plus 2, and then all of this plus c times by x minus 1. Great. So now we can go and look for x values. Our first x value we'll assign will be -2, because this will cancel out this +2 here and this +2 here, letting us find the value for c. Okay, x is equal to -2. Okay, so that means that -2 is equal to c to the -3. Alright? So, that means that we can divide -2 by -3, and this will equal c. Okay? So that means that c is going to be equal to +0.6 reoccurring. Okay, so now we know our c value. Now we need to find next we should find our a value. Okay, the way we're going to do this is we're going to set x equal to +1 to cancel out the -1 in the c and the b. Just to be clear, like when we do stuff into the b, it's actually going to make 0 times by x plus 2, which is obviously 0, and then b times by 0 is 0. So once you get a 0 multiplied by things, it'll be pretty simple. So x equals 1 to cancel out this negative 1. Okay, so that means that 1 is going to be equal to, if we look here, a to the 9th, or 9a. Okay, so we're going to divide this by 9, both sides of the equation. So 1 divided by 9 is going to be equal to 0.1 reoccurring. So A equals 0.1 reoccurring. Okay, so now we are going to actually find our B value. So we've already cancelled out basically everything that we can. So we can input the next best thing. So we'll say x equals, we got to find something that won't cancel out anything. And then we can find B. How about we do -1? X equals -1. So that means that -1 is going to equal A, and then A is A -1 plus 2 squared. Okay? So -1 plus 2 is 1. And then squared is going to be 1. So equals A. So -1 equals A to the 1 plus B to the -2 times by 1, or just -2. Great. Plus C to the -1 minus 1, or -2C. Great. So now we can actually input the C into C and A into A. So that means that -1 is equal to 0.1 reoccurring plus B to the -2 plus C, or in this case C is 0.6 reoccurring. 0.6 reoccurring to the times by -2. Okay. So, in order to do this, first we should probably simplify 0.6 reoccurring times by -2. So let's do that real quick. Okay, this will equal approximately 0.1 recurring plus B to the -2 plus -1.3 recurring. Okay, so now we can just make it so we isolate the B to the -2, and then we'll isolate B. Okay, so that means that -1, and then here we're going to want to add 1.3 recurring. So -1 plus 1.3 reoccurring is 0.3 reoccurring. So we'll rewrite this. 0.3 reoccurring is equal to 0.1 reoccurring, okay, plus b to the negative 2. Alright? So that means that we'll just subtract 0.1 reoccurring from this. So that means that 0.2 reoccurring is equal to negative 2b. Okay, so now we're going to divide by negative 2. So let's do that. You can probably use a calculator for this if you want, because they're quite large numbers. Divided by negative 2. So this, in turn, is going to equal negative 0.1. Okay, so we actually have some really yucky numbers here. We have all reoccurring numbers, so this is going to be a bit more difficult than the last one. Okay, so we are going to, again, write what each variable is equal to. Okay, so A is 0.1 reoccurring. B is negative 0.1 reoccurring. And C is 0.6 reoccurring. Okay. Wow. Okay. Now we'll just plug them back into this. Integral of A, in this case, 0.1 reoccurring over x. Oh, that was a while ago. I forgot what it was again. Over. Is this it? Yes, this is it. Over x minus 1 over x minus 1 dx plus integral, and then b, negative 0.1 reoccurring over x plus 2 plus integral of 0.6 reoccurring over x plus 2 squared. Okay, so this will be where I leave you, and you can work these out with a calculator quite simply now that I have showed you how to do these sorts of things. So you can have a go at these and finish it if you want, but that is how you integrate using partial fractions and how to integrate partial fractions. So thank you for watching this video, and next video I might talk about integration by parts, which is very similar to U substitution, or decomposing non-partial fractions to get partial fractions, which you can then integrate using this method. So